Right, good evening, everyone. Right, we want to look at our lesson today. We are going to look again at loci and with specific focus on mechanisms. This is a revision task, so we are going to concentrate on making sure that we recap and consolidate our understanding on loci, right, with particular emphasis on mechanisms. Like I said, this is a revision task. We are not going to dwell much in terms of explanation. We go straight to the exercise itself. Remember, these words: I hear and I forget, I see and I remember, I do and I understand. The emphasis with technical subjects is about doing in order to understand what you are doing so that you'll be able to apply on your own. So let's get our pencils, let's get our drawing board and a paper, and let's get straight to it. Enjoy the lesson and good luck. All right, okay. We have got the given information with regards to today's task, right? A linked crank mechanism consisting of a crank OB, right? So we've got O to B, that's our crank, joined by a link AC, A to C, which is fixed at point B, right? The two are fixed at point B. What it means, they are pin joint. Link AC is joined to link CD. We also have got C to D and is fixed at point C, right? They are joined here at point C. D is a fixed point and cannot move. We have got point D. If we look at our detailed diagram, we can actually see that it's a fixed point, right? A detailed drawing of the mechanism. Let's push this one slightly. You'll find that this is our detailed diagram, and this one is our schematic diagram, which is our line drawing. Right, and a schematic diagram, like I just said, it's a line drawing which represents, right, especially the center of the system in terms of the materials or the components which are used. Right, as crank OB rotates in an anti-clockwise direction, link AC and link CD pivots around B and C respectively. Right, what is it that we are supposed to do? Draw to scale 1:1 the given schematic diagram of the mechanism, include all the labels, trace the locus generated by point A. Right, so we want to find the locus or the path which is followed by point A as crank OB rotates in an anti-clockwise direction. Right, that is for one complete revolution of the mechanism. Show all necessary constructions. Like always, when we are starting with this, let's start by drawing a faint horizontal line, like that. Then also a faint vertical line. There you go. Right, we are given that OB is from here to there, that is 22. So we need to measure 22 as our radius. Right, which is this point. Then we describe Right, this is the path which is followed by point B. We can label that one. This is our point B. Right, once we have gotten this one, right, you find that we can as well outline this. Like that. Then you have got AC. Right, let's see if we're given distance C to E. Right, so that is the distance from here to there. We are not given that. But what we are given, right, we are given the angle at which this is drawn. This is 45 degrees, right? 45 degrees from point B, right? We have got a line like that. Then we also have got 45 degrees to line D, right? So we can make use of an adjustable set square, right? Measure 22.5. We draw a faint line like that. What we are given is O to E, right? That's O to E. That is 32, right? So from point O to point E, right? So if we get point E somewhere here, we drop it down, we would naturally be able to get point C. So let's measure 32 OE. Then we drop this one down like that. Right, we are also given that A, B, right, that is B to A, that's 58. Then we also given that B to C, that's also 58. Let's just check and verify. Right, that's about it, which is 58. Then we can take this distance. Right, which is the same as this one. We mark, we have got point A. Right, at some point this side, we are going to describe an arc like that. Then we need to define an angle of 45 degrees from this line, right? Already we have got 22.5. So if we draw another line from here, like that. There you go. Right, we'll end up getting point D. Right, and this D, right, this is our point C, this is our point B, that's our point A. We can label this point C, point D. Remember, point D does not move. Point A, which is here. So we have got A to C and C to D. Right, this can be outlined as well. Then we also outline this. There is our point E, like that. Right, so we have got now our system in position in terms of the apparatus. Right, we have got the crank O to B. right? We have got the path which is supposed to be followed by point B. We have got A to B, which is 58. We have got B to C, which is also 58. We have got C to D, which is also 58. Right, so this is equal to that, which is equal to that, and this angle there is 45 degrees. So what we need to do now, right, we divide the circle into 12 equal parts. Right, so those are the divisions. Right, so here we have got our point is 0, which is the starting point. Then we have got, if it is moving anti-clockwise, we've got point 1, point 2, point 3, point 4, 5, 6, 7, 8, 9, 10, and 11. All right, so we are going to shift the position of B at regular intervals. That is the division of the circle. Now, once we have done this, we can also define the center lines. There you go. Let's extend a little bit to show that there's also a center line there. Right, so what we want to find is the locus of point A, but ultimately would also be forced to find the locus of point C, right? In the process of doing what we are doing, we would also be able to find the locus of point C. Let me just show, this is what you can do if you want to show that a certain point cannot be moved from its position if it is not pin joint, right? So you can show something like this. There you go. Right, okay. Right, so point D would allow movement, but it cannot be removed from that position. Right, so we are going to stand at point 1 and also stand at point D, right? And you take the radius like that. So that would enable us to find the locus of point C, right, which is this one. Right, so if I stand here at point 1, describe an arc like that, then stand at point D like that. We now have got a new position. We can call this one C1, right? Stand at point 2 like that. Then also again, remember, this would not move away from point D, so you have got this, which is C2. So what is obvious, you'd find that in terms of motion, we are not going to change this path, okay? Right, the movement in terms of point C, right, would always be following this path here. Right, so if we move from here, right, we can also, that's C3. That's C4. C5. C6. C7. C8. C9. C10. C11. And you have got the starting position. Right, so what it means is that from this point to that point, that is the full extent of point C. So we can actually outline from here to there. Right, that is the path which is followed by point C. I'm going to outline this. It's not required, but we can define this in terms of the answer that we are going to need. Right, so we outline this. Right, so from the lowest point to the highest point, that is the locus of point C. So we can as well label here locus point C. This is the full extent of the path which is followed by point C. Now, we were taking point B from its initial position, moving on to the next position and so forth. What is also important, we can also define, right, the direction of rotation like that. Now, once we have done this, we can also now connect point C1 to B1. Remember, this is B1, B2, B3, B4, B5, 6, 7, 8, 9, 10, 11. These are the new positions of point B. Right, so we have got C1, which is here. Right, sometimes it's necessary. You'll find that as you do a number of, right, okay, that is for point C, and as you can check, that's for point, right, this one would be for point 8, okay? Right, so we connected this to there. Faintly. Right, so we do the same for 2. Right, let me just verify again. There you go. That's 2, like that. Then we have got 3, which is this one. Like that. Then we have got 4. Right, so from C4 to B4, We draw a faint line like that. Then we've got 5. Like that. We've got 6. Then 7. Let me just indicate there. That's our 7. 8. Let me also indicate for reference purposes. Then we've got 9. Then 10. Then 11. Like that. Right. So these are the connections from point C all the way from the lowest, like this one, to the highest point, like that. Right. Okay. So we have got from C to C1, C2, C3, then C4, 5, 6, 7, 8, 9, 10, and 11. Right, so these are the points which are linked to the locus of point C. Right, once we have got the lines which are connected from point C, right, we know that the distance from here to there, or directly from point C to there, that's 58 times 2, but we want to take from here, which is the same radius, like that. Say, for example, we start, this one was our initial position, which is that. Then if we go to 1, we go to 1 like this, then we mark, and that would be A1. Right, so that's our A1 like that. Right, that's our A1. We go to 2. 2 is here, right? We mark. That's our A2. We go to 3, which is here. We mark this. That's A3. Then 4 and 4. A4. Then we go to 5, which is here, and 0.5 is there. A5. Right, we have got 6, which is here. That's our 6. We have got A6. Then 7, which is there. That's A7. We go to 8. Then we also stand at 0.8. This is a new position for point A. We call it A8. Then we go to 9. and we go to point 9. Then we call it A9 like that. Then 10, which is here, all the way to point 10, we mark. We have got A10 like that. Then last but not least, it's point 11, which is C11 this side and B11 this side. So what we want is A11, then we label A11 like that. But remember, you can do this without necessarily labeling, but I want you to be able to follow later on your own and do this as well. So once we have gotten that, we can join these points. First of all, just to check, right? If you are able to create a certain pattern, then you connect. But you start faintly. So that is the draft in terms of our locus, in terms of the path which is followed by point A. Remember, point A is here, right? So once you are satisfied that you have done the right thing, you can now outline this path. Can start from the other end. There you go. Right, so that is the path which is followed by point A as crank OB rotates in an anti-clockwise direction, and ultimately through that process you'll find that you would also be able to generate the path which is followed by point C. Right, so the next thing that you would want to do is to simply come here and label locus point A like that. There you go. You would have done, right? You would have completed the task which you were given in terms of finding the locus of point A. Right, I hope these exercises that we are doing, they are opening up your mind and you are able to follow, and you should be able to apply these concepts on your own. Right, I'm going to just start another exercise. I'm not going to complete it. I want you to complete it as an exercise on your own. Right, so let's turn over and see the other side in terms of our next revision exercise. I hope you enjoyed what we did just now. Let's see if you can now do it on your own in terms of application. So we're just going to start as the framework and you will finish that on your own. Right, the instructions are as follows. Right, a linked crank mechanism consisting of a crank OA right? Consisting of a crank OA joined by a link AB, right? So you have got O to A, that is the crank, right? And there's also a link A to B, right, which is fixed at point A. So this crank OA, right, is connected to the link AB at point A, right? That's the pin join. Link AB is joined to link BC. We have got B to C, right? And is fixed at point B, right? Again, there's a pin joined there. C is fixed and cannot move. Point C is fixed, right? And it cannot move, right? So what it means, just from the look of it, it can simply swing about, okay? And allowing this one to rotate. Right, a detailed drawing of the mechanism, that is the detailed drawing, a schematic diagram of the mechanism, this is the line drawing, which we refer to as the schematic. As crank OA rotates in an anti-clockwise direction, right, the movement is anti-clockwise. Link AB and link BC pivots around A and B respectively. Right, what is it that we are supposed to do? Draw to scale 1:1 the given schematic diagram of the mechanism, include all the labels, trace the locus generated by point P, right? At some point, we talked about this one as a pin, which is located on the link for one complete revolution of the mechanism. Show all necessary construction. If time permits, of course, yes, we can do this and complete this together. Let's start, right? First of all, you need to start by drawing a faint horizontal line like that, and a faint vertical line like this. Right, we are given that OA is 25 millimeters in terms of the radius, so we measure 25. But the moment it is a crank like that, we know that we are supposed to draw a circle. Right, that circle is representing the path which is followed by point A. So you copy the way it is drawn, not just a circle, but in most cases it's centerline line, which is what we have here as well. Right, and we are also told that this angle is 30 degrees. So we are going to describe, draw a line. Let me just extend. So that we see the actual cutting. Right, so that is point A here. Right, then we are also told that AB, right, is 50 millimeters. Right, AB is 50 millimeters. And O to C, it's 50 as well. Right, so that's the distance from here to there, which is O to C is 50. So let's measure 50. Then mark a point like that. Right, and we have got AB is equal to 50. So I'm going to do this. Take this distance, which is 50, stand at point A and describe an arc like that. Then C to B is 30, but I'm going to measure 30 millimeters. What is critical with mechanism is to copy the information properly. Right? Then stand at point C, right? And describe an arc like that. Right, you connect We also connect this one. Then we can outline our system. And last but not least, there you go. Right, the next thing is to define the center lines. Is a max. Right, so you define the center line. So we have got O to A, which is our crank, right? And we are told that it moves in an anti-clockwise direction. So we can also define the direction like that. Okay, right. So the direction is shown. We have got point B, we have got point C. Right, just like we did with the last exercise, we can also come here, just do this. Right, then you can just show that when you do this, you are showing that this part cannot move. Right, okay. Now, we have got also A to P, which is 25 millimeters, right? So let's measure 25. That's our point P. Right, that is the one that we should be able to find the locus for. Right. Let's complete this by dividing the circle into 12 equal parts. Remember, in EGD, speed is critical. So there are three things which are critical, right? That's your speed, that's your neatness, and that's your accuracy. Right, so this is our point 0 in terms of movement. So we've got point 0, that's point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Right, back to point 0. Remember, it's moving in an anti-clockwise direction. So we are going to shift the position of point A such that at intervals from 0, it goes to point 1, right? But we know that this point is not going to move. The only possible motion which it can assume is, right, stand here, right? So we describe an arc like that, right? So point B, no matter what, it can only be located on this arc. So if we take the distance from A to B, right, and we stand here at the new position of point A, like that, we now know this is our B1, B2, B3, B4, B5, right, B6 on the other side, B7, B8. B9. B10. And last but not least, that's B11. Right. So the full extent of motion in terms of point B is from this point to that point. Okay. Right. So we can outline this. We know it's not required, but just to make sure that we explain this one fully. Right, so that is the full extent of the movement of point B, okay? Right, once you have done that, you can now connect B1 to A1, then B2, which is this one, to A2, and so forth. Right, let's do that. Right, we have got B1 to A1, right, then B2 to A2, right, B3 to A3, then B4 to A4, then last going up, it's B5 to A5, like that. Then we've got B6, we have got B7 to A7, right, we've got B8 to A8, B9 is here, then B10, then B11, let me just verify. That's B11 to A11. Then once you've done that, you take the distance from A to P, right, A to P like this. You go to point 1, right, that's P1. You can label this. That's P1. Then you go to point 2, you mark like that. And that's P2. Then 3. That's P3. You do the same for 4. That's 5. P5. P6. It's P7. P8. P9. P10. And last but not least, it's P11. Then going back to the starting position. Right, so we need to join this point. This is P11, P10, P9, P8, P7, right? Then 7, 6, 5, 4, 3, 2, 1, then point P. Right, let's connect. So that is the path that is followed by point P, right? As the crank revolves about point O, right, with this part not moving, right? Remember, point B can only move along this arc, right? We cannot stretch this one, so it can only swing, right? As point B swings like that, it would push, right? Point P there, right? So we can outline this now. There you go. Right, so that is the locus which is followed by point P, right, for one complete revolution of crank OA, right, which will be moving in an anti-clockwise direction. So we can come here now and label locus point P. Right. If you do this, right, in an exam, you would be guaranteed that you would have, right, scored high marks. So boys and girls, I hope you understood what we did today in terms of our consolidation with regards to loci and mechanisms in particular. Right, so tomorrow we are just going to look at our final exercises on link mechanisms, right? That is our 2-hour session, right, from 9 to 11. So I hope you enjoyed this lesson as much as I did, and all the best in your practice work, and good night.